Hello everyone, welcome you all. Today's topic is CDMA simulation using MATLAB. Here we are writing a MATLAB program for simulating CDMA transmitter and receiver. Before we start to write MATLAB program, so we will try to understand what is the objective of this video. So initially we will see how spreading concept is useful for implementing CDMA. Later on we will move on to what is CDMA block diagram, how it operates, and then we will proceed for algorithm for simulating CDMA transmitter and receiver using MATLAB, and then we will proceed for program implementation. Later we will go for observation and the results of the simulated program. Finally we will conclude with advantages and disadvantages of CDMA. Now let us start with how spread spectrum concept is useful for implementing CDMA. Actually CDMA stands for code division multiple access. It is a multiple access technique just like DMA and TDMA. We can observe here in case of CDMA all the stations are transmitting their information at same time and same frequency. Here all the stations are provided with different chip, or you can say like PN sequence. Now we all know that spread spectrum has a huge transmission bandwidth. On using DSSS system, if we communicate a single user, so it will be no doubt a wastage of bandwidth. So as a part of which DSSS system in fact provide the multiple access technique, because here we are using a different code words or the chips for different stations. So that will help us to enjoy the multiple access facility called code division multiple access. Now in CDMA each user is provided with a unique code that is called PN sequence. Almost all the PN sequences are uncorrelated, in the sense they are all orthogonal to each other so that they will not interfere each other. So this advantage we are getting because of PN sequence, as a part of which we are using PN sequence for implementing code division multiple access. Advantage is very simple. At the same time and same frequency we could be able to transmit different stations over the wide band of spread spectrum. So now we will see what is a CDMA block diagram. Let us observe there are different stations are available here. So here around n different stations are there. You can even observe that a noise is also added at the stage of multiplexing. So you can see station 1 is carrying a data called D1, station 2 is carrying a data called D2, and station n is carrying a data called Dn. And all the stations are BPSK modulated and they all are provided with different codes called chip 1, chip 2, chip n, like that. So these chips are called usually PN sequences because they are of very high frequency data, right? So this original bit pattern is of very small frequency and this chip rate is of very high frequency. So if I multiply high frequency component with a small frequency component, then no doubt the multiplication gives us very high frequency component. So that is our S1 of t, S2 of t and up to Sn of t. Means it's very simple. Regular BPSK for all the incoming signals is done. All the incoming BPSK pattern is done. But the codes are given different to all the stations. Regular BPSK for all the incoming data for different stations are done with carrier cos 2 pi FCT, and all stations are provided with different code words. They are C1, C2 up to Cn, and all these different stations will communicate through a CDMA technique. Means over the single frequency spectrum all the signals are moving. Okay, now it's very challenging for the receiver to determine from which station which data is coming. Okay, so that challenge has to be decoded or has to be solved by the receiver. So this is a very interesting concept, like why CDMA is that much useful. Fine. So here receiver should know from which station which data is coming. So for that reason, so receiver should be aware about what are the different code words used by the different stations. Okay, if the receiver is aware of or what are all the different code words used by the different stations, then no issue, receiver could be able to determine what is the data is coming from which station and what is the data. From which station data is coming and what is the data. That is the major role of these receivers to be determined. Fine. So after that, once you come up with what is the data is coming from which station, then you will be moving to demodulating the BPSK signal. Okay. So I feel I can proceed. In order to implement the MATLAB code, so we are having this small algorithm. Please have a look of it. Initially, we will generate a random bits to be transmitted over the CDMA architecture. Fine. And then initiate a chip pattern for each station. It is already stated in the previous block diagram. Each station is provided with different chips or PN sequence. So that's what we have to initiate the chip pattern for or PN sequence for each station and randomly allocate the bits to the different stations. So this is very interesting task actually. Okay, bit we have generated. After that we have taken a chips and then we are randomly allocating the bits to different stations. After that, each bit coming from the different stations should be appended with respective chip sequences as a CDMA encoded bits. So please understand this. For each bit coming from the different stations, okay, append a respective station's chip sequence as a CDMA sequence. Okay, is it clear? Like, it's very simple. If any bit is coming from a particular station, then we will be appending a respective station's chip sequence as a CDMA encoded bits. So we will enjoy that even in the code also, what exactly it is happening here. So other than that, at the receiver end, we will collect a 6 bits of CDMA sequence at a time and make a dot product of selected bits with the PN sequence of each station. Then if the dot product results of a station is 6 or minus 6, then it is clear that the bit is transmitted from that particular station. Please make sure that the dot product result of all the stations should not go for 6 minus 6. In that way you have to select the PN sequence. Okay, any one among the available stations, any one of the result of available stations should go for 6 minus 6. Then we can say that the bit is transmitted from that particular station. Now, before we go for advantages and disadvantages, we will try to understand what is the code actually. Okay, we all know that these are the 3 instructions used for the MATLAB code initially, because CLC will clear the command window, clear all will clear command window and workspace, and close all will clear the backend programs. Now coming to this, you can observe here it is a generation of random bits which is to be transmitted over the CDMA architecture. Fine. So now R as a variable I am taking, so it is a round between random of 1 comma 10. What does it implies? Random of 1 comma 10 will generate 1 row 10 columns random number. Okay, so after in the range of 0 to 1. Okay, rand 1 comma 10 will generate a random numbers of 1 row 10 columns, and that random number is generated is in the range of 0 to 1. Okay, after that you see what is the round is doing here. What is our R? R should be of binary, means either 0 or 1. So whatever the random number generated, it is in the range of 0 to 1. So to make that like round I am using, so that if the number is generated random number is less than 0.5, it will round it to 0, and if the number generated random number generated is more than 0.5, it will round it to 1. So this is the beautiness of this instruction, so that I could be able to get R as a binary data which is generated random. Okay, that data is of 1 row 10 columns, means 10 different binary data we have generated, and I am displaying the same data. After that, we have to assign the chip pattern for different stations. We are using here only 3 stations: station A, station B and station C. Okay, see here, A of 1s means whenever A is carrying bit 1, so I am using one particular PN sequence or a PN sequence string, you can say, like pattern. So this is a pattern I am using for A of 1s. A of 0 means when A is carrying 0, what should be the pattern? So it is minus 1 times of A of 1s. It's very simple. You have to decide only for chip pattern, only a chip pattern for A of 1. Okay, A of 0 goes to minus of multiplied with A of 1. Okay, in the similar way we will be having for the B station. For the B station, what is there next? B of 1s is equal to, once again another sequence I am taking. Okay, and then B of 0 will be minus 1 times of B of 1. Okay, similarly C of 1s, another pattern I am taking, and C of 0s will be minus 1 multiplied by C of 1. After this, what is our algorithm is telling? We have to allocate different bits. We have to allocate the bits randomly to different stations. So that is our next task. Okay, so we have 3 stations. Okay, as a part of which I will consider 3 switch cases. Okay, later we will address that. Okay, whenever means after allocating a particular random bit to a particular station, I supposed to generate CDMA sequence also. So that's what I am initially taking CDMA sequence as a empty matrix. Okay, as and when I am generating a particular CDMA sequence, I will append that CDMA sequence in my CDMA sequence matrix. Okay, it is an empty matrix I am initializing currently. After that, you can observe here, for counter is equal to 1 to 10. Can anyone tell us why I have taken counter is equal to 1 to 10? It is very simple. As my bits are ranging from 1 to 10, for each bit I will be incrementing my counter. So that's for counter ranging from 1 to 10, which implies that I will run further code for each bit at a time. Fine. So I am considering first bit, second bit, like that. Means what is our task here? Our task is to allocate a particular bit coming from the R means data, right? Whatever the particular bit coming from the R, I have to allocate it to randomly to any one of the stations. So that's what, to allocate randomly to any one of the station. So I am using this instruction. What is this telling us? Switch random integer 3 1 1. What does it implies? I mean, what is this 3 is telling? The random integer, whatever it is generating, it should be in the range of 1 to 3. Okay, and at each time I am generating 1 row 1 column, means random integer 3 comma 1 comma 1 will generate either 1 2 3. Among these 3, one number is generated. So that is random integer 3 comma 1 is giving us. Okay, whatever it is generated, that is given to the switch operator. Okay, means if the random integer 3 comma 1 is generating number as a 2, then switch 2 means case 2 has to execute. If it is generating one number, means random integer 3 comma 1 is generating number as a 1, then it will, this switch statement will switch to case 1. Example you can see here, case 1 is there here. Okay, means in this way randomly we can allocate a incoming bit to a 3 different stations. Okay, so that's what randomly we are taken here, because in real time it can happen randomly. That's a reason. Okay, when switch is telling us first bit is coming from, case 1 is telling me that first bit will come from station, it is allocated to station A. Okay, that's what. If the R means what? Original data, right? If R comma counter is equal to 0. If R is equal to 0, then you are allocating CDMA sequence as what? A of zeros. You can see, if your original bit is of 0, then you are allocating CDMA sequence or as 0 on appending CDMA sequence, which was, see, this CDMA sequence was empty matrix. To that empty matrix I am appending A of 0. Okay, so when we are doing this, whenever your data is of 0, okay, if your data is of not 0, then you will be allocating CDMA sequence of A of 1s, CDMA sequence as A of 1s. See, we are doing appending. Okay, initially CDMA sequence is 0, you can observe it is a empty matrix, right? So here we are allocating as per incoming bit. If the incoming bit is of 0, then I am allocating A of zeros. If the incoming bit is of 1, then I am allocating A of 1. Allocating in the sense I am appending CDMA sequence with A of 1s and A of 0. So case 2 implies what? The incoming bit is allocated to station 2. Okay, that incoming bit, if it is 0, then you will be appending CDMA sequence with B of zeros. Are you understanding here? Whenever your random number is allocated to station A, then your CDMA sequence goes to A of 0. But whenever your random number coming is allocated to station B, then CDMA sequence will go to B of zeros. Okay, station B, but bit is of 0, then B of 0. Station B, if the bit is of 1, then we will be appending B of 1s. Similarly, whenever an incoming bit is allocated to station 3, you will be appending C0 for incoming bit 0. You can observe, if incoming bit is 0, you will be appending C0 to the CDMA sequence. If incoming bit is 1, then you will be appending C1 to the CDMA sequence. So this is how, see, summarize. I will do simple summary in 2 sentences. Like, initially what we have to do, we have to allocate, we have to first of all get a random numbers. Okay, then we have to take a PN sequence for each station, then initiate CDMA as a empty matrix. After that, randomly allocate the incoming bit to the 3 different stations. That's what I have taken this switch instruction. Okay, so this complete switch instruction will run for 10 times. What is the reason? Because I have a 10 bits to be randomly allocated to 3 different stations. Whenever it is allocated to first station, then you will check whether the incoming bit is 0 or 1. If it is 0, you will be appending A0 to the CDMA sequence. If it is 1, you will be allocating A1s to the CDMA sequence. Likewise, you will be doing for station B and station C. Fine. After that, we will display what is the encoded or what is the CDMA sequence we have generated. After that, so now we will be moving for decoding part. Let us observe what we will do in the decoding part. It is very, very interesting actually, because how your CDMA decoding or detection happens. See, I am taking one counter is equal to 0. Okay, for selector ranging from 1 is to 6 is to 120. What is the meaning of this? 1 is to 6 is to 120. I am collecting 6 bits each time. I am collecting 6 bits each time, and I am proceeding with the, actually if your data is of 10, then your range of selector will be from 1 to 60. If your data is of 20, then the range is from 1 to 120. Okay, so now can anyone tell us like why I am taking this instruction? At the receiver end, I have to select initial 6-bit and I have to determine from which station it is coming. So that's what 1:6:60 means. It is very simple. I am gathering 6 bits at a time. I am gathering 6 bit at a time and I will compare that with the PN sequence, whatever the PN sequence given to each station. Okay, are you understanding? This instruction is very important. 1:6:60 means I am ranging from 1 to 60 with a space of, with a what you can say, steps of 6. Okay, initially 6 bit, later on 7 to 12 and then 13 to 18. Likewise, bits you will be taking from the CDMA sequence. So for that reason, I need this selector is equal to 1:6:60 so that I can make a 10 groups of 6 numbers because my initial number is 10. So that's the reason. Okay, if your initial pattern is of 20, then it will be 1:6:120. Fine. Now when I proceed inside the for loop, we will be taking counter is equal to counter plus 1. Means I am handling first 6 selected bits. I am handling first 6 selected bit. After that, you can see how to select 6 bits of sequence. So temp is equal to CDMA sequence of 1 comma selector, means first bit of CDMA, second bit of CDMA, third bit of CDMA. Likewise, up to 6 bits of CDMA I will be taking it in the temp as a variable. Okay, after that what am I doing? It's very simple. Result 1 is equal to dot product of A1 of temp. Whatever the 6 bit I have taken now in the temp, I am multiplying that, I am making a dot product of that temp with A1. Similarly, I am making that temp dot product of temp with B1 and I am making dot product of temp with C1. So I am storing all these dot product result in result 1, result 2 and result 3. So after this it is very simple. You can observe that if the result 1 goes to 6 or result 1 goes to -6, it's very simple. It's very simple that the bit 1 is coming from station 1 or station A. Are you understanding? It's very interesting part here. How am I detecting from which station the data is coming? See, if the result 1 is what? It's a dot product between temp and A1. If the dot product between temp and A1 is either 6 or -6, then my bit is coming from station A. And if it is 6, it implies that if it is 6, then it implies that the data is 1, else data is 0. It's very simple. If result is equal to 6, then data is 1. If result is equal to -6, then data is 0. But from where the data is coming? The first bit. See, the first bit is coming from station A and the bit is depending on either 6 or -6. Similarly, if result 2 is equal to like this, then bit 1 is coming from station B and the bit, which bit it is coming? If result 2 is equal to -6, the bit 0 is coming. If result 2 is equal to 6, the bit 1 is coming. Similarly, station C. Okay, so this is how the CDMA simulation can be done in MATLAB. Now, shall we run this code and we will observe what is the result and what is the observation find. Fine. So let us see. So I am using here Octave rather than MATLAB. Okay, let us see. So this is the output we have got because I have already run the code. You can observe there are 10 bits. R is equal to 10. You can observe here there are 10 bits. Fine. And CDMA sequence, usually for 10 bit, how many CDMA sequence we will get? For each bit, 6 bits of CDMA code, correct? So that's what I will be getting 60. You can observe I will be getting 60 CDMA sequence, because each bit, each bit of this R will give you 6 bits. So as a part of which 10 bits of this R will generate you 60 bits. Okay. After that, you can observe that result 1. So result 1 is leading to -6. What does it implies? See, other two results are 0. Result 2 and result 3 are 0. Result 1 is -6. What does it imply? It implies that the bit 1 is coming from station A. And if it is -6, then the bit is 0. Okay. In the second case also you can see it is randomly allocated, no? In the second case also the bit is coming from station 1, because result 1 is equal to 6. That's what you can say, right? The bit is coming from, see, the bit 2 is coming from station A once again, because result 1 is 6, correct? So you may even ask like, sir, result 3 6 is there or not? You can observe here result 2 is equal to -6, means the bit number 9 is coming from station B, and if -6, then the bit is of 0. Okay. Likewise, so you will be able to determine from which station the bit is coming. Means how many times the different bits are coming? 10 times the different bits are coming. So those are all the 10 different possible result cases, and its conclusions we are listing here. Fine. So I think you would have understood this concept very well, and for your further studies, these are all the advantages and disadvantages of CDMA. You can go through. I'll wait for a while. Many users of CDMA use the same frequency. Okay, so you can easily understand these concepts. So these are all advantages and disadvantages of CDMA. I hope you enjoyed this CDMA simulation by using MATLAB topic. Okay, thank you for your patience listening. We hope we will have a next video with next new topic. Thank you for your patience listening. Have a nice day.